Good evening. I thought I'm going to talk about the temperature switches tonight. And since we have shown now the control unit, how this kind of connects, and we focus more on the valves for the vacuum elements or vacuum actuators of the flaps. We have looked at what the pump does, and we have looked at the monovalve and how that is activated when it is activated. But now the question arises is, why do we have 5 temperature switch or temperature sensors in it, not just switches, but actual sensors? I guess the main philosophy is to create a comfortable climate atmosphere in the car. And that is a system which basically evolved out of the standard heater, with your manual slider and the fan control you had back in the 60s, 70s, 50s probably too. With the air conditioning then coming in with an extra switch, and you turn the hot air or hot water off, hot temperature off. So this was to be a climate control where they can mix this whole thing together. And there are 2 feedback sensors in this basically. One is the one which is mounted in the light, in the, what do they call that light actually? That's a good question. In the overhead? No. Now I'm drawing a complete blank. The interior light. We have a reading light and the regular interior light, which comes on and off with the door, contacts. There is the, what do they call it? In-car temperature sensor. And it sits there right above between the 2 sun visors, and you can take it out. I'm going to talk about the resistance curves here in a minute. That sensor is basically the main feedback sensor of what the temperature is approximately inside the vehicle. And in order to improve the accuracy, they're running a probably half inch rubber hose in the headliner, down the A column, all the way underneath into the dashboard behind the hand glove box or your passenger side airbag. There is a little tiny pump which draws air. It's basically a blower which sucks air. So and these blowers tend to go out because they run constantly as soon as you turn the ignition on. They're not activated by the air ACC unit. They're directly wired into the ignition system, so that blower runs every time you run the car. And if you can imagine, after 33 years, these brushes wear out, so this little blower unit goes out, and then there's no airflow going. And that's when these units become fairly erratic, because that is really the main feedback sensor of this. So with the dial, we dial in the desired temperature we want, and this entire unit then will trying to achieve the temperature you have dialed in, measured on that in-car temperature sensor. That is the basic principle of this, and it can increase automatically the blower speed, the air blower speed, and how much air comes through. And you can select the different vents depending on which button you push. When there's cold desired, they blow usually through the front outlets. If you want more warm, then it usually goes to the foot compartment and some on the windshield, the defrost outlets. And it can be varied, and the unit will adjust that while it is working towards the set point. The 2 primary feedback systems in this is for heat is the heater core temperature sensor, and for the air conditioning system is the evaporator temperature sensor. That basically tells now the ACC of whether the pump and the monovalve are open and the heater core temperature rises, and it will automatically turn the heater core off. The heater core temperature sensor, or the unit, the ACC, will turn the heater core off at about 85 degrees. And the way they do it is to either turn off the pump or they turn off the monovalve, or turn on the monovalve actually, because that's what cuts off the heat. And then they can regulate actually the heater core to a certain temperature, by regulating the water and pulsating that monovalve fairly slowly. You can regulate the amount of hot water coming in there. That measured by the outside temperature sensor will tell them, well, the 10 degree, I'm going to do it now in Celsius. Say like the outside temperature is 10 degrees Celsius. So the cold air coming in is going to be 10 degrees cold, and you're moving so and so much air through it. The ACC knows that because they know at what speed they're running the blower. So you have an air volume movement there, and then you can calculate this on how hot you have to make the heater core basically. And that will give you then a temperature. And that usually works that way. That's say like if the in-car temperature is very low and you have set this to a fairly high degree, then the core will be fully heated. The heater core will be hot. And as closer you get to the set point, is more the monovalve starts now to actually being turned on and off, on and off, on and off in a pulse width, very slowly in a second interval. And that usually happens in the middle settings. And that will regulate the heat down in the heater control. And that will then climatize the air temperature coming out of the system closer towards the ambient temperature you have desired, you want actually in your car. That's for the heat side. And the air conditioning system basically works similar. So just for 1 second before we go to the air conditioning, the heater temperature, the heater core temperature sensor basically prevents the heater core from getting too hot, so it won't melt the plastic or do any damage inside this, and shut this off. And the turn off point is 85 degrees Celsius, and that is an important thing. So it has two functions. It has the function is to actually regulate the core temperature, and also to prevent a over temperature inside the climate box, the whole assembly there under the dashboard. Now with the evaporator sensor, temperature sensor is basically the same story. That will measure the temperature of the evaporator when the compressor is running. And there again is the function is to not so much to regulate it, because you pretty much need cold air, but you don't want the evaporator to freeze over, which is quite easy, can be done. I had many years ago 190 E 2.3 liter, and the temperature sensor was out. It wouldn't sense the temperature correctly, so the ACC thought that the evaporator was much warmer than what it actually was, and the unit would start to ice over. And what happens is when they're starting to ice over is that there's no more airflow from the blower coming through, being pushed through the evaporator. That is blocked off, and then you basically have to turn off or go to the economy mode, the EC mode, so the compressor cuts out, and then you have to wait, and then that all starts to melt down, and then you feel the air suddenly coming through there. That is usually caused by a bad evaporator temperature sensor. And that is the same thing when these units go erratic, very erratic, where they suddenly turn off. There's only cold air coming in, only warm air, or the AC goes in and out. That is usually caused by the in-car temperature sensor, and primarily because that little blower doesn't work anymore. But now back to the evaporator temperature sensor. So the primary function of that unit is to prevent icing on the evaporator. And the cutout point is 5 degrees Celsius. So when the outside air coming in is too cold or too humid, then you will have ice build up. So they decided to set the cutout point at 5 degrees Celsius, which is around 40 degrees Fahrenheit. That's when the compressor would cut out. And of course, if there's enough warm air coming in, which is taken out, then you don't have to worry about it. The compressor won't cut out. But in this overall scheme, is especially with the later units, which I had described yesterday, which have the microcontroller in it, they can actually mix the air temperature. So they can now cycle the heater core and they can cycle the evaporator and bring them to a particular desired temperature. So you can now dehumidify the incoming air or the fresh air coming in, and you can put out a target air. That works extremely well at night. And then this whole system basically puts out a stable temperature. And that happens in that middle range. The water temperature sensor, that B108 I believe it is, has the function to monitor the coolant when the air conditioning system is running. And as you may know, is on your dryer you have two switches. One switch activates the low speed auxiliary fan at a certain pressure, which equals temperature on the high side, and that runs pretty much in the summer months as soon as you turn it on. And then when the engine temperature actually gets too high, it's usually around, I think, 85 or 90 degrees Celsius. That's when the ACC unit actually gets, from the reading from that water temperature sensor, B108, will turn on the other relay and switch the aux fan from slow speed to high speed. So the slow speed is turned on by the dryer receiver, and the high speed is turned on by the ACC. It will also then, if the temperature starts to further increase, cut out the compressor, I believe, at 95 degrees Celsius. So if your coolant system is not okay, you can have the compressor cycling in and out with your water temperature. And so that's why that is important, that you have the correct water temperature sensor, the B108, the B108, which I was talking about yesterday. There's these two different values which changed with model change in September 1987, the low ohm one before up until August 1987, and then the high ohm or higher ohm value after September 1987. And you have to make sure that the ACC unit you got is the correct one, which works with the sensor you have in your car. If it turns out that you have accidentally installed an older model, an older ACC for the low ohm temperature sensor in your newer model 126, then you will have to either change the ACC or you will have to change the temperature sensor. It's probably easier to change the temperature sensor. So they have to match. You have to make sure. Otherwise, what will happen is, for my investigation here I did, is the lower temperature unit will not damage the newer high ohm ACC units, which are looking for the high ohm, but it will give you a wrong reading. And basically it can go to this point that the compressor constantly cycles in and out, in and out, in and out, even though you're not even close to the 90 or 95 degrees Celsius cutout mark for that. Because the overlapping resistances, the low range would indicate that you're already much hotter for the newer versions, and they will then allow to cut in, cut out, cut in, cut out. So if you have constant cycling and you had that for a while and you change the sensor, for instance, then you've either put it was most likely the low resistance units with the newer ACC units where that happens. And you may want to take a look at this. And so so basically the system can mix the air or mix the temperature together and then put that out. It is not as sophisticated. It is a pretty crude system by today's standards. If they had the microcontrollers we're having today, if we would have had them 30, 40, or 35 years ago, then we could have regulated that even better. But in the car, because in the summer you got lots of heat, so the air conditioning is basically constantly running, the mixing mode itself is probably you can encounter that only during the spring or fall. If you live in the northern hemisphere in Europe or in the United States, Canada, and especially at night when there's no sun, then the system actually can work the way it kind of was designed. And like I said, the control is fairly simple. There's a set point, and then there's a feedback. That's the in-car temperature sensor, and the evaporator temperature sensor, and the heater core temperature sensor, and the outside temperature sensor. They're coming together, and the unit will then make a decision to add more heat or reduce the heat in the heater core, and the same with the AC. There's more control than with the heater core through the monovalve. And if your monovalve is working, you can buy that overhaul kit. I think Euro makes this. I have that installed in my car, and it is like exactly the Mercedes-Benz one, and it works perfect. So I replaced it, and again, whenever the monovalve is on, that means there's a current flowing through it that was indicated with the yellow LED. That's when the heat is off. Because it did this on default, is so if the power goes out or the unit doesn't work anymore, then you constantly have heat going through it. If you don't want heat, then you have to turn the monovalve on. So monovalve on is always no heat. And that is something to keep in mind. The pump is straightforward. Pump on means pump on. There was one viewer, I forgot now his name, he left me a comment, and he asked me what I think about the ACC unit have a input from the speed signal output, which also feeds the cruise control. It's the same signal that goes to the car radio, it goes to the ECU, and who else gets the speed signal? I think that's it. The car stereo, the ACC unit, the cruise control. I can't remember offhand right now if the idle speed control unit also gets the speed signal or only the RPM signal. I know the ECU gets both, and so the question was, does the pump turn off when the speed signal is high enough, or the frequency of the signal? It's a pulse width. It's a constant 50% duty cycle frequency control system, and I measured it at about 30 miles per hour. That's when the system comes alive, the whole thing. The output frequency is approximately 75 hertz. So you're gonna be in a 75 to maybe 800 hertz range for most of the driving, depending on the speed you're doing. And I measured it with that unit I have, the kind of exotic thing, and there it did not have any impact. I have the speed input, but the speed input did not turn off the pump. It is possible that the latest version had that incorporated, or the very first one, and then they stopped doing it. That I have to see when I get another unit to verify this, but that particular unit I have tested, it did not respond to the speed signal, to the mile per hour or speed driving signal, and there was no change in the pump. The pump was solely controlled by the temperature dial versus the in-car temperature unit in my system. As closer it reached the set point I had set with the resistor I was using for the in-car temperature, is more of a pulsing you had going on the valve, on the monovalve, and the pump eventually shut off. And the same thing when you switched over to AC, as we saw on the other video, the pump would go off first, and then the monovalve would pulse a while and then eventually stay on completely, and therefore preventing any hot water going into, hot coolant going into the heater core. So this is basically what these 5 sensors do, how they interact. There's not much magic to it. It is important that they work correctly. And what I showed you also, it was the replacement NTCs I bought. What I'm going to do is I'm going to pull out the sensors, and I'm going to desolder the old ones, and I'm going to solder the new ones into the holder bracket with the 2 pins, because that is a lot cheaper than spending $20, $40, or $50 on a sensor to replace them, when the active element you actually need to replace is $4, you know. So I bought 5 of them, and that was $20 plus $10 in shipping. So I got all 5 sensors or 4 sensors I need to replace, and 1 extra one for the price of 1 sensor, basically. And that's, I don't know if I'm going to do this tomorrow. I want to change some of the vacuum elements. I get the vacuum actuators out, and get a few things sorted out in there too. And I may do it tomorrow. I may do it next weekend. We will see. I got all the vacuum actuators or vacuum modules here, and I'm still waiting for a few parts and see how I feel about it. That is basically on how the ACC works. Like I said, it's the best thing is to download the manuals. You won't find really anything in there. Then the main thing is they're telling you is that these sensors have to work right, and if they go off, then the whole heat cooling system will not work right. And I thought I'm going to explain this in a more comfortable way here tonight, rather than in the lab or out in the car humping around and stuff like this. And I would like to thank you for watching my videos, and I would like to thank you for liking my videos, and I would like to thank you for subscribing to my channel. And with that, you have a wonderful evening and a great weekend. Thank you.